Good morning, students. Today we are going to continue the discussion on tensors for deep learning, as well as we will end up the session with some of the famous models in CNN. Okay. And as we have seen in the last section, what is a tensor? Tensor is referring to the representation of data in a multi-dimensional array. When I say tensor with one dimension, it is a one-dimensional column vector. When the tensor is in the form of a two-dimension, it is in the form of a matrix. Whereas when I say it is a three-dimension, there is another index called a channel index. Here, the 2121, 2494 are the two rows of the channel 0, whereas 7888, 8505 are the rows of the second channel, right? And what is the reason why are we going to learn about this tensor? Our objective is to make a highly computationally intensive model for learning the visual imagery, where the images are having a three dimensions, as well as for learning this image into various categories, we need to have a high computational complexity of parametric model where they have to be parallelly learn the characteristics of the image. For that reason only this tensor has been introduced. Formally, tensors are multilinear maps which are called as vector spaces to represent the real numbers in the form of either a scalar vector or a matrix. When I say a scalar as a tensor, it is represented by means of a one-dimensional tensor. When I call it as a vector, it is a two-dimensional tensor. When it is a matrix, it is becoming a three-dimensional tensor. And what is the purpose of having this tensor? As I told, it is for representing the multidimensional array of numbers. Here the numbers may be your image pixels in three dimensions, or it may be a four-dimensional MRA data, or a five-dimensional fMRA data, or it may be a multi-dimensional hyperspectral data. As the number of dimensions of the data increases, this tensor is going to hold the data on various number of channels which are present in your data, and each channel information is very much essential to be handled by your convolutional neural network for learning the characteristics of each of the channel of your input data. And for that reason only this tensor has been introduced in our model. And how it is being handled during the time of computation. When you are taking in terms of the computational architecture of your CNN by using the tensor, when we are going to use the tensor, when our dimension of the data is very much increasing and the number of samples, the training as well as test is also keep on increasing in the order of million, this tensor is going to be a very much helpful tool. And what is the basic representation of this tensor? You can see it is being represented by means of a computational graph, where there are participating nodes are there is a data flow in that, as well as there is a hierarchical arrangements of these nodes. There are two types of nodes in our tensor, which is commonly known as constant node as well as operational node. The way in which they are being connected is called as a computational graph. And these constant nodes are pushing the value from their node to the next layer's node. As you see in this graph, A and B are the constant which are defined by the Python package TensorFlow with the values assigned with 5 to A and 6 to B. So the nodes A and B here becomes a constant node. They are pushing their value 5 as well as 6 over the data flow path to the next layer node called C. Whereas the C is colored in a different color, which indicates that it is an operational node where it takes the value from A as well as B, and also it takes another flow from the computational path called the multiplication operation. And here it is not a normal multiplication as like our variables A and B. Here A is a tensor and B is another tensor, and C is doing a TensorFlow multiplication. What I mean here is A may be a one-dimensional tensor, or A may be a two-dimensional tensor, or it may be a three-dimensional tensor. When I say it is a three-dimensional tensor, it is going to perform a three-dimensional linear multiplication among the elements of A as well as corresponding elements of B. After this computation, the result is going to be parallelly stored into your variable C. What I mean is Aijk into Bijk may be stored in the variable Cijk by having a parallel computation over different kind of a similar node graph what we are showing here, but they are not dependent on each one of them. That is the power of this tensor. And apart from this conditional nodes like your constant node as well as the operational node, there is yet another concept of your TensorFlow called a placeholder. And what is the purpose of this placeholder? Normally, when you are doing a programming, you may be using a variable, constant, as well as sometime you will be declaring some of the dummy variable or local variable, right? And what is the purpose of that? You will be storing some of the temporary results or partial results into those variables. What it happens, as I use it as a temporary variable, I can reassign it with any other value or any other partial results that is not going to affect my computational process, right? So that we call it as a temporary placeholder. And the same meaning is hold good. So in this tensor also, we are going to introduce a placeholder which is going to feed the data into your computational graph, but that feeding of data will change from one instant of computational time to another instant of computational time. What I mean is, for the first flow into the graph, it may be holding a image 1. When the second time of flowing the data, it may be holding the image value 2. So like that, on every flow into the graph, it may be holding different in training data or testing data sample in its storage space. That is called as a placeholder, right? So what is the purpose of this placeholder? I already told you. We will define what is this placeholder. If these placeholders are initially an empty space and they are used to feed actually the training as well as the testing samples into your CNN model. I am showing here two of the syntax for defining the placeholder. One is the 32 type float point, another is the 32 bit integer type. Whereas for a 32 bit float, we are going to use it for representing our normalized images, and here the backside represents the number of image I am going to put it into my placeholder. So now this placeholder is capable of storing the images. How many images it is capable of holding? It is going to hold batch size number of images. That means if I say batch size equal to 10, my placeholder here is going to have 10 channel in it. Each channel will be representing one image. Suppose I use it as a three-dimensional tensor. And suppose I say it is a two-dimensional tensor. What will I do here? I will be linearizing my image into a row of pixel. And now what will happen? My tensor will be represented by each row. So I will be having the patch size of 100 row, and each row will belong to one image. Okay, that is the way. And here what is the next representation I am using here is the label placeholder. This label placeholder is for storing the desired output for each of your training sample as well as testing sample images. And they are purposely used for identifying the desired output, okay, during the time of training or during the time of testing. Now let us see the architectural connectivity between our TensorFlow as well as your front-end language. Here, the TensorFlow is actually a deep learning library developed in Python. Recently, it is launched by the Google as open source. Anyone can make use of this. And this TensorFlow is going to create a multi-core execution system over the CPU or a GPU or Android or a iOS platform or any other OS platform. And at the front end, it can be accessed through either a Python or through a C++ coding. And when your computational size of the data is very large, it can be handled only by GPU. We cannot handle it with the help of a CPU, right? And what is the significance of the TensorFlow? If I see an application which is not going to use the TensorFlow and which is going to be developed with the help of the TensorFlow, what is the significant change I am going to achieve from this TensorFlow? That we will see now. Here I am showing a hand digit recognition example where the input size is 28 cross 28 pixels, and that is going to be given directly as an input to my softmax classifier, and this softmax classifier is going to generate one of the 10 digit label, right? Why it's 10 label? There are 10 digits, 0, 1, 2, 3 up to 9, and each image is going to be handled by the softmax classifier in a serial manner. That means when I am feeding the input to this model, it will take only one image of the digit at that time. As I shown here, it takes only the 8 digit as an input, which is represented by a 28 cross 28 matrix, and those 28 cross 28 pixels of this image are flattened into a serial line of 784 pixels as it is accepted as the input layer, which contains 784 input nodes, right? And these input nodes, let me call it as x1, x2 up to x784. and they are going to be connected with your softmax layer output y0, y1, y2 as well as y9. Okay, and they are going to be connected through your hidden neurons, which I am not shown here, but I can have as many number of hidden neurons here by having a reduction of the 784 input pixel in an incremental manner as 600, 400, 200, 100, 50, 20. Then finally I can connect with the 10 digits. It's up to us how far we wanted to make it as a divisions. And after this node, it is going to go through a softmax classification. As you all know, softmax is doing a weight sum of all the input pixel along with the bias and decides the softmax score with respect to all the other class labels. And now the same model, when I am expanding into a TensorFlow, what is the major significant difference here is it is not going to handle serially all the images. Now it is capable of handling a set of images or a batch of images simultaneously. As you can see in the last figure, there is only one row in a model which represents one image, whereas here there are many rows are there and each row represents one such image. The corresponding image label is shown here. Earlier it was only 8, but now it is taking the input images 8, 4, 6, 6, 4, randomly, like up to 100 images it is taking. Each image is represented in one line. And now what happens, my tensor is a 2D tensor which has a row as the image and column as the image pixels, right? And so parallelly, what happens is the learning happening through a weight matrix as well as the learning equation, that is the linear equation between your input as well as your softmax model is being represented through a L00, L01, L02 up to L09. What it means is the relation between your 0th sample the to belong to 0th digit. The relation between your 0th sample belong to digit 1. So among the 10, only 1 is going to be dominant based on the corresponding bias, and that is going to be the label of your given image. It is expected that the first row belongs to digit 8. So L08 is going to dominate among the 10 scores. Like that, for every 100 image, it is going to happen a parallel execution, and parallelly you are going to get all the outcome, and they are not going to run in one single core of the platform on the TensorFlow. They are going to run parallelly on various core, and they are going to be simultaneously executing your input image, and you will be getting the result in a microsecond delay. And this is the way in which the batches of images are being assigned through your TensorFlow. So this is your linear equation between your input X and the weight matrix W as well as your 10 bias terms, right? So the 10 bias terms are being represented, and they are represented by a one dimensional tensor of size b of 10. Okay, and whereas the weights are having a 748 input from each of the pixel, and they are going to be connected with the 10 of your softmax, and you can take it as a two-dimensional tensor. And whereas your image is also a two-dimensional tensor, where the 100 here represent the number of sample, whereas 748 is representing each of the input pixel. And this is the way you are going to identify your tensor dimensions. Okay, and what is the prediction happening in your tensor with the help of your desired output label? If you see, for every one sample you will be having a desired output, right? And for 100 samples I am going to have a prediction of any one of the score. As I told in the last slide, they are going to give a value as either L00, L01, L02, right? So those values are being stored as a prediction score. Among the 10 score, only the 8th score of the first row will be going to be the maximum compared with the other score. That is the way the TensorFlow is working. And this is sample code I am giving it to you for running this example in a Google Colab. So open your account in Google Colab, copy this code and put it into the code block box and run this, and you can see the outcome of this model where there are 70,000 data samples of handwritten digits are being taken. 5 epochs are being run for training as well as validation. At the end of fifth epoch, what you will see is the training accuracy will be 98.63, whereas for validation data set accuracy, what I am going to get is 98.06. But it may vary for your trial because it is going to be assigned with a random weight as well as a random